Foiling and factoring. This is a review. You guys have done foiling and factoring since probably 7th, 8th grade. But this is a review of some things that are a little bit more difficult. Some of this factoring is. But you know foiling, and I feel really comfortable with your foiling and being able to do all of this. It's just multiplying two binomials. And but that has a lot to do with factoring, and factoring is like the backwards foiling kind of thing. But I wanted to go through these four types of factoring with you because we're going to start using those to solve parabolas. And so the greatest common factor is the first thing that we use for factoring. We factor out a greatest common factor. Um, and then we'll have another kind of factoring that's like trinomials. That's like our product sum thing that we've done for a long, long time. And then the difference of squares we've done. I think you're going to recognize a lot of this. And then perfect square trinomials. So let's just run through those again, just as a review, because I want y'all to work on these, practice these, so that it'll come easier for you when we apply them to the next step. So when I look at A, this very first example 2, part A, let me get me a ballpoint pen. The first thing I'm going to do is do the GCF, and then I'm going to factor by grouping. That's another way that you've worked these. But what I'm going to first do is look at my 9y cubed, my 6y squared, and my 3y and think, what is it that they all have in common? And what they have in common is a 3 and a y. And so what I'm going to do is factor a 3y out of the 3, and I'm going to put inside what the result is. So 9y cubed, when I factor out a 3 and a y, I get a 3y squared. My 6y squared, when I factor out a 3y, I get 2y. And then when I factor 3y out of 3y, I'll actually get a 1. And so that's factoring out the greatest common factor. But now I'm going to group these. I'm going to do a product sum thing because this is a trinomial. And this one's different in that we have a 3 with our y squared. And so we have to do 3 times 1 for the product, which would be 3. And then our sum is always that middle term no matter what, which would be negative 2. So I want two numbers that multiply to give me 3 and add to give me negative 2. And I know 1 and 3 are the only things that multiply to give me 3. And they'll add to give me negative 2 if 1 is positive and 1 is negative. But in this case, I can't really factor this because 1 times 3 is 3. And negative 1 times negative 3 is 3. But for this to be a negative 2, I would have to have like a negative 3 plus a 1. And that would give me negative 3. So this is not going to factor. So we are finished right here. That's the only thing I have to do there. So let's go to B. I'm looking at this and there's 4 things here. There's 4 terms. And so I'm going to do this by grouping. Factor by grouping. That means I'm separating the first 2 from the last 2. And I'm going to pull out the greatest common factor out of the first 2. And what they both have is a 2. And then they both have an A. So what's left here, when I take a 2A out of my 8/8 square, I get a 4A. And when I take a 2A out of my 10AB squared, I get a 5B squared. Then the second 2, what they have in common is a B. And so I'm going to factor out a B. That leaves me with a 4A in the first blank and a 5B squared in the second blank. Okay, I can factor this further if this is the same as this. And I'll do that by factoring out that actual parentheses. And when I do, what that leaves me with is a 2a plus b. And that is factored. That's fully factored. So let's move on down to factoring trinomials. You know these better because there are product sum ones and you've had a lot of practice on these over the years. And so I'm going to do the product and sum of this trinomial. And so I'm looking at this first number in front of my x squared, which is a 1, and 1 times negative 24 is negative 24. On these, you usually just use the last term, but that's what's actually happening as you're multiplying this 1 times that, and then a sum of 2. So I'm going to think of two numbers that multiply to give me negative 24 and add to give me 2. So I don't know all the factors of 24, so I'm just going to go down the list. So 1 and 24, 2 and 12, 3 and 8, 4 and 6, and 5 doesn't go in it, but 4 and 6, I'm noticing they are 2 apart. So that's a really big possibility that this is going to work. If I want to get a positive 2 by adding these two together, I'm going to need a 6 minus 4 to get that. So these are my two numbers that multiply to give me negative 24 and add to give me positive 2. And so they're going to be able to be factored like this. And that's how you factor that trinomial. So then when I get to b, I'm going to go back through that process I went through a minute ago. I have a 2 in front of my y squared. And so I'm going to take 2 times negative 18, which gives me negative 36, and my sum is going to be 9. So my factors of 36 are 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 and 6. Well, I want two numbers that are going to be 9 apart, and 3 and 12, if I subtract those, they'll give me 9. So I know I'm going to use these two, and I'm going to use, since I want a negative 9, I need my bigger number to be negative, so I'm going to make that a negative 12 right here. And so I'm going to use these two numbers because they multiply to give me negative 36 and they add to give me negative 9. So I'm going to, because this has a 2 in front of it, I'm going to leave that. I'm going to put negative 12y plus 3y minus 18. And what's happened is I'm using my numbers here to replace my negative 9. Because negative 12y plus 3y is not negative 9y. Then I'm going to group these, and I'm going to factor out a 2y, which gives me y minus 6, and over here I'm going to factor out a 3, and that gives me y minus 6. And since my parentheses are the same, I'm going to take y minus 6 out, and that leaves me with 2y plus 3, and that's fully factored. It doesn't matter if I put my negative 12y first or my 3y first when I rewrite it up here in this step, but it seems to be easier if you put the negative one first if you've got the option of a negative and a positive. So that's just something to keep in mind. Now, if I want to factor perfect squares, or the difference of squares, when I factor this one, you could do product sum, and that's completely fine because you've got 25 and 10. And so if I go down the list, basically I have 125 and 5 and 5. And 5 plus 5 is 10, and 5 times 5 is 25. So this factors like x plus 5, x plus 5. And so that can even be written as x plus 5 squared. And we will use that for perfect squares. Then when I do a difference of squares, I think you'll remember this, First of all, what I need to do is look at this and go, okay, what do these have in common? And I know they have at least a 3 because 3 goes into 12 and 3 goes into 27. And 3 goes into 12 4 times. But that's going to leave 4b to the 8th. And this is going to be 9c squared. And so from here, though, when I have a binomial, in other words, I have 2 terms, then what I'm looking at is maybe possibly them being perfect squares. And so my 4b to the 8th is a perfect square because 2 times 2 is 4. And b to the 4th times b to the 4th is b to the 8th. So what goes here and here is the 2b to the 4th, because that's what multiplies together to get 4b to the 8th. And then I'll do a plus or minus, and my 9c squared is the same thing as 3c times 3c. So those are repeated, so those go here and here. And then that is fully factored. I like those because they're pretty quick, and I know you remember those. There's some easier ones than that one, but that's how you can do one of the more difficult ones. So the rest of this is checking your progress. I want you to look at what we've done above and use that to practice the rest of these. And I want you to do that tonight so that when you come to class tomorrow, we can really look at those and you can ask questions. But that is all that you have to do today. Tonight, you're going to watch this factoring video and you're going to check your progress on the stuff that I just showed you to do. So have a good evening, and I will see you tomorrow.